In this lecture, we're going to learn about function pointers. And function pointers are a mechanism we have in C++ to be able to store addresses to functions and use them to call those functions afterwards. If you think about it, a function is really just a block of code somewhere in the memory map of your C++ program. So if somehow we can grab that address, we can reuse it to call that function later in the execution of our C++ program. Let's first look at the syntax of how we can do that. Here is a simple example. We have a function to add two numbers. It's going to return double. It's going to be taking two parameters of double type, and it is going to do whatever it does in the body of our function here. Now, if we go in our main function, we're going to see different syntaxes we can use to set up function pointers. And the first one is what you see here. We just say the return type as you see here. Then we set up a pair of parentheses, and inside we put the pointer symbol, and then we say the variable name for this function pointer. Now, some of you must be saying, this is crazy. Why would I set up my variable like this? But this is really what we have to work with. This is how C++ defines variables that are function pointers. So this is going to be the variable name. And then after this first pair of parentheses, you're going to set up a second pair of parentheses, which is going to contain your parameter list. And you don't have to specify names. You just have to specify the types for these parameters. After you do this, your variable will be set up. So to set up the variable, you have to do this entire thing we have here. And after the variable is set up, you can initialize it with the address of a given function. So for example, we have set up a pointer to a function that returns double, and that takes two double parameters. All we need to do is give it a function that meets these requirements. And we can either pass the address of the function explicitly using the address of operator, or we can pass the function directly just like we do here, and either of these two forms is going to work. We can initialize our function pointer with an assignment like we do here, or we can even do this using braced initialization, and this is going to work as we see down here. We can even use auto type deduction. So I am trying to show you all the different forms you can use. So we can do auto type deduction here, and the compiler is going to deduce that fptr is a pointer to a function. We can even use the star symbol here, and these things are going to give us the same thing in the eyes of the compiler. Once we choose to use one of these forms to set up our function pointer, we can go through the function pointer and call our function as we see here, and this is going to work really well. Now, again, some of you must be asking, why would I go through the trouble to set up a function pointer? Well, this is going to become very useful when we get to passing functions as parameters to other functions to set up what we call a callback mechanism, as we are going to see starting in the next lecture. But in this one, we are just learning the basics of function pointers and seeing how they work. Another thing you can do is initialize your function pointer with null pointer, and we can do something like this. Another thing you should know is that the compiler is not going to allow you to initialize your function pointer with null pointer if you set it up using auto type deduction, because the compiler won't really know which kind of function to deduce. So if you do this, you will get a compiler error. Okay, now that we know these things, let's head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is function pointers. We are going to grab our template files and put them in place. Let's open this up in Visual Studio Code by dragging and dropping here. Okay, here we have our main CPP file that we can clean up a little bit. And we're going to set up a function to add stuff up. So it's going to return double. Now, if we go down in the main function, we want to set up a function pointer to this function here so that we can reuse it later in the execution of our C++ program. So the first thing we can do is set up a function pointer variable. The syntax we saw in the slides is really a little bit awkward, but that's what we have to work with in C++. You first specify the return type, and then you set up a pair of parentheses. You put a pointer symbol, and then you specify the variable name for this function pointer variable. We're going to say fptr to say that this is a function pointer. Let's call it this way. And after this pair of parentheses, we have to specify another pair of parentheses in which we're going to put our parameter list. Okay, so our parameters are going to be double and double as we see in the function. And after we do this, this will set up a variable that is going to be a function pointer to a function that returns double and takes two double parameters. Once we have this, we can assign a value to this. We can either assign the address of our add function like this. This is going to work. And if we go down and try to call our function through our function pointer, you're going to see that this is going to work. So we can go down and say stdc out, either is going to do, and we're going to say fptr. We're going to go through the function pointer and call our function here. You see, we can pass in our arguments 10 and 30. And if we build this program, you're going to see that it is going to work. We are calling our function through its function pointer, and the compiler is going to figure out that we really want to call this function here because we are going through its address to call it. This is what we are doing here. The build is good. As you can see here, we can bring up a terminal window to try and run this program. Can clear and run Rooster, and you see that the sum is 40, and this is exactly what we expect. So this is our first syntax to set up a function pointer. We can even pass the function name directly, so let's do double and say fptr and pass in our parameter list. We're going to say double, and then we're going to assign the name of the function to our function pointer variable. Again, the name of our function pointer variable is set up right here. Don't forget this. So we can go through this name again to call our function, and this is going to work. This is a syntax that is supported in C++. We can build our program and pass it through our GCC compiler. The build is going to be good. We can clear and run Rooster. We're going to get the same result. It is also possible to go through braced initialization. So if we go down and do something like this and use the address of our function like we have done before explicitly, this is also going to work. You're going to see that if we build our program, this is going to go through. The build is going to be good. We can clear and run Rooster, and we're going to get our sum printed out here. It is also possible again to pass the function name directly. So let's grab our thing here and use that down below. And we're going to say the name of the function directly without the address of operator here. This is also going to work. We can pass this through our compiler to try this out. The build is going to be good. We can clear and run Rooster, and we will have our sum printed out here. We can also do auto type deduction. So we can say something like this. We can grab this little thing here to save on typing a little bit. And we will not set up the function pointer variable with all this text here. All we have to do is say auto fptr. This is going to be deduced by the compiler. The compiler is going to look at the signature of this function and deduce its function pointer. And we can go through this to call our function. You're going to see that this is also going to work. We can pass this through our compiler. And auto type deduction is not going to work with braced initialization. This is the error we have here. But if we use an assignment, I think this is going to work. So let's pass the function name directly, or we can even pass the address. I think this is also going to work. So let's build. We're going to pass this through our compiler. We have two equal signs. Let's take one out, and we are going to do something like this. And now the build is going to be good. This is going to work. We can even use this syntax here. We can also pass the function name directly. So we can comment this out and say auto fptr and say equals add. And this is going to assign this function to this function pointer variable, which is going to be deduced by the compiler. If you hover over this function pointer variable, you're going to see that the compiler is going to deduce a function pointer variable as we have seen before, and this is really cool. We can pass this through our compiler to make sure it is working as we want. The build is going to be good. We can clear and run Rooster. This is also going to work. We can even use the pointer symbol in front of the function pointer variable. This is also going to work. So we can take this out and paste this down below here and adapt it to do something like this and use the pointer symbol here. This is also going to do function pointer deduction. You're going to see that if we hover over our function name, we're going to see our pointer variable, or function pointer variable to be exact. If we build our program, we're going to see that the build is going to be good, as you see. And if we clear and run Rooster, we're going to get our result here. So this is good. We can comment this out and go down and pass the function name directly and use the pointer symbol here. This is also going to do the same thing. If we hover over this, you see that this is a function pointer variable. And if we build and run this program, it is going to do what we want. The build is good. We can clear and run Rooster, and we have our 40 here. Hopefully you can see that we have multiple ways we can set up function pointer variables. One thing you should know is that a function pointer variable is tied to the return type and the parameters we have in our function. If we set up a function pointer variable with a different return type, for example, and try to assign the add function to this, you're going to see that we get a compiler error. Let's try this out. We're going to go down and say things gone wrong. And we're going to set up a function pointer to a function that returns int, for example, and it is going to be fptr, as we have done before. And the function is going to take two double parameters, and we're going to assign add. Let's see if this works. If the compiler actually accepts this, you're going to see that the compiler is going to say, I can't do this. You have set up a function pointer to a function that returns int and takes two double parameters, but you gave me a function that returns double, so I am not going to accept this assignment here. You are doing cross assignments between variables of different types, and the compiler doesn't know what to do with this. It's going to give you a compiler error. You need to be aware of this. So the function pointer variable has to match with the signature of the function you want to point to through that function pointer variable. This is the message I am trying to convey here. You see invalid conversion from double pointer to int pointer, so this is not allowed. We have this compiler error here. Another thing is that it is possible to initialize a function pointer with null pointer, so we can make this guy double here. And assign add, you're going to see that if we do this, this is going to work. Let's make sure the build is good to rule out any kind of typos that we might have done. The build is good, so this is working, but we can initialize this with null PTR because null pointer is a zero pointer or a pointer that doesn't really point anywhere. But because this function pointer isn't really pointing anywhere, trying to call a function with this function pointer is going to be a recipe for a disaster, because if you do this, the compiler won't know which function to call. Let's try to do that. We're going to pass this through our GCC compiler. So the build is going to be good, but if we try to call this function through this function pointer, we will get a crash because the compiler won't find the function that we expect at this address here. Let's see what we get if we run this program. So we can clear and run Rooster, and you will see that we get a crash because we are really trying to use whatever lives at this address as a function. So make sure you don't call functions through function pointers that have null pointers inside. That's going to be a recipe for a disaster. Okay, so this is really all I had to share in this lecture. I hope you found it interesting. The main message was to show you the syntax to use to set up function pointer variables. The syntax is what you see here, and you say the return type. After that, you specify the variable name prefixed with this pointer symbol, and then you set up another pair of parentheses in which you're going to specify your parameter list. Please make sure that the signature for your function pointer matches the signature you have for your function. If they don't match, you will get a bunch of compiler errors. It is possible to assign a null pointer to your function pointer variable, but if you do that, make sure to not call that function, because if you do, you will be setting yourself for a disaster. When you get to the point to call your function, you're going to get a crash probably, and that's not what you want. We are going to stop here in this lecture. In the next one, we're going to show you how you can use function pointers to set up callback mechanisms in your C++ program. Go ahead and finish up here. and meet me there.